Today's lesson is on compound inequalities. What is a compound inequality? It's two inequalities joined by the words and or. And represents the intersection of the two inequalities. What solutions are in common? Use the symbol upside down U. Or represents the union of the two inequalities. So we combine the solution and we're going to use the symbol U. For and statements, the value must satisfy both inequalities. For the or statement, the values must satisfy one of the inequalities. Let's look at an example. We could have 7 less than x, and x is less than 15. So we can rewrite it as one inequality, reading 7 less than x and less than 15. So down here another example. -3 is less than x, which is less than 5. Can be read as x is between -3 and 5. Down at the next example, -3 is less than or equal to x and less than or equal to 5. This one can be read as x is from -3 to 5. Notice here, what's the difference in the two inequalities? In the second one, we got less than or equal to. So we can't use the word between. We need to include -3 and 5, so we say from -3 to 5. A couple more examples. 3x is greater than 2x minus 5 greater than 6. Notice this is written as one inequality. So this will be an and. 5x minus 3 is greater than 4. And, so we know we have an and, or an intersection. -2x plus 6 is greater than 1. Or statements. They're always going to have the word or. So we have 1/2 x minus 7 less than or equal to 5, or 4x minus 2 is greater than 6. Let's look at the and statement. A compound inequality containing and is true only if both inequalities are true. Both inequalities are true. The graph of a compound inequality containing and is the intersection of the graph of the two inequalities. The intersection of the graph of the two inequalities can be found by graphing the two inequalities and determining where the graphs overlap. The symbol for and is the upside down U. Let's look at the or statement. Compound inequality containing the word or is true if and only if one or both of the inequalities are true. The graph of a compound inequality containing or is the union of the graph of the two inequalities. The symbol for the union is the U. Let's graph an example of a compound inequality. So right now we have x is less than 10 and x is greater than 5. Let's take the first inequality and let's graph it. Since it's less than, we have an open circle at 10 where the symbol's pointing left, so we're going to point left. Go to the second one. X is greater than 5. If it's greater than, we have an open circle. The symbol's pointing right, so we point right. Remember, we can only point in the direction if we have variable, symbol, value. Now let's look at where these two graphs overlap. Overlap between 5 and 10. So we're going to have open circles at both. We're going to fill in all the numbers between 5 and 10. Look at that graph. Other graph. Okay, let's graph an OR statement here. We have negative 3 is less than x, or x is greater than or equal to 0. So I need to graph 0 and negative 3. I'm going to graph these separately, and then we'll look at it. Negative 3 is less than x. That's not in the form variable symbol inequality, so we need to switch around. And then I need to switch my symbol. So we want an open circle at negative 3. My symbol's pointing right. So I'm going to point right. Now we're going to do the second one. X is greater than or equal to 0. So I'm going to have a closed circle at 0. That one's pointing to the right too. Okay, this is more of a complicated problem because they are both pointing in the same direction, but we have OR. Only one of these has to be true. They don't have to overlap. So here, our solution starts at negative 3 and it goes to positive infinity. So we got an and. Graph the solution of 3x minus 1 less than or greater than negative 28 and 2x plus 7 is less than 19. The first thing we need to do here is we can't graph this on the number line yet. So we need to solve for x. So let's add 1. If 3x is greater than negative 27, then we'll divide by 3. We get x is greater than negative 9. We're going to now solve the second inequality. 2x plus 7 is less than 19. We're going to subtract 7 first and then divide by 2. We get x is less than 6. So where do these two graphs overlap? Here's the first one, or the second one. X is less than 6. We got an open circle pointing left. Now we have an open circle with negative 9 pointing right. Where do these two overlap? We have our circle and open circle with negative 6, open circle with negative 9, and we have all the numbers in between negative 9 and 6. So, could we rewrite this differently than this? We could make this, every and we could put in this 1. I'm going to make x in between. Smallest number is what? Negative 9. Largest number is 6. Both of them open circles, so we have less than on both. Let's look at an OR. 3x plus 9 is less than negative 3, or 2x is plus 1 is less than 5. We need to solve for x here. Subtract 9, divide by 3, we get x is less than negative 4. Solve the second one. Negative 2x plus 1 is less than 5. Subtract 1, divide by negative 2. Notice the sign, the inequality here is less than, it's greater than here. Why would that be? That's right, when we divided by a negative number here, negative 2, remember we had to split the sign. So we went from less than to greater than. So we have x is greater than negative 2. So let's graph the first one, x is less than -4. We have an open circle at -4, pointing left. If the x is greater than -2, open circle, symbol's pointing right, point right. When we have or here, it satisfies both statements, one or the other one. All right, let's try another one together. 2x greater than x plus 6 and x minus 7 is less than 2. First thing we need to do is solve for x. I get all my x's on one side here, so I'm going to subtract x by like terms. I'm left with x is greater than 6. Second one, I'm going to add 7 to both sides. X is less than 9. In both of these, I have variable, symbol, value. It's going to be much easier to graph this way. First inequality, I have x greater than 6. So I need an open circle at 6. I'm pointing right. Second one, x is greater than 9. Open circle at 9. I'm pointing left. Where do these two graphs overlap? Between here, right? We have an open circle at 6, open circle at 9, and we have all numbers in between. Could we have written this differently as one inequality? X is between smallest number on the left, largest number on the right. Okay, let's go back to the last lesson. Can we write this as a interval notation? Smallest number comes first, 6, comma, largest number. Do we have a parentheses or a bracket? Remember when it was just less than, or we had just the open circle, it was parentheses. Another just less than, or an open circle, so another parentheses. Remember, this, and the graph all mean the same thing. Let's look at this one. Is this an and or an or? Well, it's written as one inequality, so this is an and statement. First thing we need to do when it's written as one is divide it up into two separate inequalities. 3 less than 2x minus 1 is the first inequality. 2x minus 1 less than 5 is the second one. Now let's solve both for x. I have 1. Divide by 2. I have 2 less than x. We like the variable on the left, so let's switch it. Variable, symbol, remember when we switch, we have to switch the symbol too. So x is greater than 2. Go to the second inequality, we have 1, and we divide by 2. X is less than 3. Here we have variable, symbol, value, so we're good. Let's get, since it was written as 1, we probably should put it back as 1. How do we do that? X between smallest number 2, largest number 3. Can we write this as interval notation again? Smallest number, comma, largest number. We have just less than, so we have parentheses. Lastly, we put a graph. X greater than 2, open circle, pointing right. X less than 3, open circle, pointing left. Where do these two graphs overlap? Just in this area here. Open open circle, between. We look at our inequality here, our compound inequality, x is between. So that graph makes sense that we have something between. I would like for you to practice these last 4 problems here on your own. I'd like for you to solve each inequality, write the solution set in interval notation and as an inequality, and graph the solution set on a number line.